this function here, as you see. So it is 1 divided by 1 plus e to the power x dx. I mean, the very thing, whenever you are given an integration problem, then we need to classify with which type of integration techniques that we are going to apply here. So for example, I mean, this is not a standard way of finding the integral directly, so that is excluded. And then, is it an integration by substitution? When we say integration by substitution, then that means we need a function and it is derivative. I mean, if we take a part of the integral, then you find the derivative also inside the integral. And now obviously we cannot directly do this, and also it is not integration by substitution. So now let us see what we do here to integrate this problem. So we rewrite it down here again. So 1 divided by 1 plus e to the power x dx. So this is the integral again. Now we can write it as follows. So we say, okay, this is 1 divided by 1 plus e to the power x again. But now what we can do is we can for example multiply by e to the power x and divide by e to the power x, and now we will see why. I mean, this kind of integrations, they require a bit of skills, and those skills, they just come from practice. So the more you practice, then the more you learn. So from here, now we multiply. So this will be equal to, if we multiply here, so that will be e to the power x, and divided by, here we would have e to the power x plus e to the power 2x dx. And also we can write this integral as follows. So we can also say this is e to the power x divided by e to the power x plus e to the power x all squared, because this x 2 times x is just 2x. So there is nothing can here. But now, I mean, now you see why did we do that, because we are planning to use maybe integration first by substitution. I mean, now obviously when we do this, then we will have a function and then it is derivative inside the integral. So that means if we take u here to be u e to the power x, for example, then we get the derivative here up, which is also e to the power x. So let us do it here, the substitution. If we say, okay, let us say u is equal to e to the power x, then that means so that means du will be equal to e to the power x dx. So then from here we see that everything up here, that is will be du, and then because this is here is equal to this, and then we just replace here e to the power x by u, and then we replace e to the power x by u. So that means after using this substitution, our integral would become, so we do not to change the color. So again, so that will be, I mean, everything here will be du. So that means here we have 1 divided by 1 plus sorry, that is here u, because e to the power x is u, plus u squared du. So from here, so that will be equal to, we can rewrite it again as, so we say that is 1 divided by u times 1 plus u, and then everything here is multiplied by du. So now, I mean, the question, how do we integrate this now? I mean, this obviously we can use integration by partial fraction. So I mean, the idea of using integration by partial fraction is we write this function here as follows. So we say, okay, our function 1 divided by u times 1 plus u, this can be written as a constant, which we don't know yet, but of course we find it. Then here we would have u in the denominator plus, then again a constant, divided by 1 plus u. So now I mean the main idea is just to find those two constants here in this case. So but then before we do this, so let us do the following. So here we have u times 1 plus u, and then we divide this by u, and then we get 1 plus u, and we multiply by a. So that means we have a times 1 plus u, and then here also, so we divide this by 1 plus u, and then we get u, we multiply by b, so that means we get bu here. And then from here you see that we have 1 is equal 2, so we can do it here. So we have 1 is equal to a times 1 plus u plus b times u. So and now I mean what we are doing is we are interested in finding the value of a and the value of b in this case here. I mean obviously, I mean if we let us just imagine that, I mean here we can, I mean if this is 1 and this is negative 1, then so those are two possible values for a and b. I mean if this is 1 and this is, I mean if this is 1 and this is negative 1 here, a and b, then we would have 1 plus u minus u, it is 1. So that is correct. But then I mean the idea here is to choose two values for, I mean this is just an equation. Now let us say it is independent of the integral. And now because if it is depends on the integral, of course we need to be careful about our choice of u. But I mean just for the sake of solving this equation, I mean any value of u would satisfy this equation, of course. Here let us say that, for example, u is equal to 0 here. So and then I mean the idea is we would like to cancel one of those constants. If we set u is 0 here, then that would be that would vanish. So that means we have 1 is equal to a, right? So a is 1, because here we have 0 also. 1 plus 0 is 1. So and now let us choose the second value. So which value would vanish a, which is obviously here u is negative 1. So we can choose u to be negative 1 in this case. If we put negative 1 here, then that would also cancel, and here we have 1 is equal to negative v. So negative v, that means b is equal to negative 1. And then just as we said here, so now this function, I mean if you substitute, then you will get also the same functions. So I mean that means let us continue our integral. So now we know that 1 divided by, because we would like to integrate this function here, but first we reduce it. So then here we would have u, 1 divided by u times 1 plus u. So that is equal to, we can say, so we have 1 divided by, this is a is 1 divided by u, and then b is negative 1. That means we have minus 1 divided by 1 plus u. And so I mean now we can integrate both sides. So that means integral of 1 divided by 1 plus, so u times 1 plus u du, then that will be equal to integral 1 divided by u du, then minus integral 1 over 1 plus u du. So now it is symbol, I mean this is linear, the integration, so that is linear, and that here will be ln 1 plus u. So now we have everything. So we will have ln u, so inside the absolute value, I mean again we choose the value for u here to be independent of anything else. I mean if you would like it to do it perfect, then you choose a value carefully. I mean like you choose u maybe to be 1, and here you choose it to be 2 or something like this. But I mean, that is of course correct, because when you substitute here, then you get the same thing. So, and then here we would have minus ln 1 plus u, and then plus a constant. So, but now I mean the integration was respect to x. Then that means we need to put here we need to put, so we need to replace u by e to the power x. So that means here we would have ln which is e to the power x minus ln, here we would have 1 plus e to the power x plus a constant. I mean here that will be just x, because this will go behind, and then the natural logarithm for e is 1, so x minus ln 1 plus e to the power x plus constant. So I mean, of course, if we would like to take the derivative of this function, I mean, if we differentiate this function, then we must get our original function. I mean, if we integrate, then here we will get if we differentiate, let us maybe do it here just to make sure that your solution is correct. Then we need to take the derivative of this function. I mean, let us call it anything, let us call it I, because it was the integral. I mean, if this integral is I here, if this is I, let us call this I. So I here is now x minus the natural logarithm is 1 plus e to the power x plus a constant. So if we take the derivative here in this case, di with respect to x, then here of course we get 1 minus, here we get 1 over these functions, then multiply by the derivative of this function. So then we get this. So here 1 plus e to the power x, and the derivative of constant is of course 0. So then if we do this, then we get, so here we would have 1 plus e to the power x, and then when we multiply here we get 1 plus e to the power x, and then here we get minus e to the power x. So those would cancel, and finally we will get our the function that we integrated, so which is this one. So that means our solution is correct for this problem. So now let us proceed to the second one, second integration. So here let us do the second one. So the second problem is integral cosine 6x divided by cosine 3x plus sine 3x. I think that is also a nice integration problem here. I mean, because firstly it is obviously it is not just directly, we cannot just write the answer directly, and then second we cannot, I mean, there is no function and it is a derivative. I mean, that means if it is by substitution, then you split your integration into two parts independent of the constants and everything. Then we need to have one part is a function and the second part of will be the derivative of the function. That also here we cannot do. And now also by substitution, that would also, sorry, by parts, that would also not be possible, be more complex. So this means we need to think again, I mean, in such integration, so that, as I said previously, requires a bit of skill. So let us try to do it together here. So I mean, we can say this integral, I mean, let me call it I here. I prefer just to call it I, and instead of rewriting it again in the future, then I would just say that is I. Of course it is a function of x. So but now that is I for integral, so we'd say I will be equal to, this integral will be equal to, so what we do, similar, the same idea. So here we have cosine 6x divided by cosine 3x plus sine 3x as well. So dx. Here before we write dx, let us see what we would like to do, or what we plan to do. So here what we need to do is to multiply by cosine 3x minus sine 3x, and then at the same time we divide by the same. So we divide by cosine 3x minus sine 3x, and then we say dx. The idea here is we would like to use the identity, the identities of trigonometric functions. And then here, if we multiply, then we get the following. So that will be integral here. Then we have cosine 6x times, here we would have cosine 3x minus sine 3x. Then we divide it by, so now here that is a difference of, write it as a difference of squares, of course, because here that will just be cosine squared 3x minus sine squared 3x, the denominator, then times dx. So now this integral will be reduced to the following. Here, so we already know that this will be equal from using the identities. If we have cosine of sum of two thetas here, 3x plus 3x, then that will be equal to cosine 3x cosine 3x minus sine 3x times sine 3x. Okay, so then that is exactly this. So cosine is cosine squared, and then 3x sine times sine is sine squared, then 3x. So that is exactly here. So that is exactly this one, which is cosine 6x. So here what we get, so we have already cosine 6x, then times cosine 3x minus sine 3x, then everything here we divide by this, which is in this case cosine 6x, right? So dx is very important to not to forget it. So now those would cancel out. So our integral will be, cosine, here we have cosine of 3x minus sine of 3x, then dx. So we close it, parentheses, and then finally now that is easy to integrate, right? Because the integral of this is your third. So sine 3x, and now the integration of negative sine, it is cosine. So that means here we would have, because when we differentiate the cosine, then we get negative sine. So then here we would have cosine 3x. Here we also have third, so plus a constant. So that is the end, and thank you very much for watching. And if you are interested in more videos, I would not say difficult integration problems, just in general integration, differentiation, if you are a high school student or first year university student, or just doing anything about calculus or mathematics, please make sure that you subscribe, then you will receive more videos, and thank you again.